Hey guys, in this video, I'm going to show you how you can solve any multi-body system in under 30 seconds or less, regardless of what the problem is asking. So they can ask you to solve for the tension in the string, the acceleration of the blocks. Maybe they ask you to solve for the contact forces in between two blocks. Whatever they ask you to solve for, you can do it using this method. Now, normally the way you solve these systems is you draw an FBD for each of them. You make a equation using those FBDs for each of them, put those equations together, you rearrange, and then you solve. That process is pretty tedious and it takes a long time. The method that we're going to use is we're going to first solve for the acceleration of the system. Once you have the acceleration of the system, that will allow us to basically solve for anything else very quickly. Now, how do you solve for the acceleration of the system? Well, we're going to use the net force of the system. So F net of a system is equal to the mass of the system times the acceleration of the system. And the reason this works is because all objects in a multi-body system accelerate together, which means that this object and this object have the same acceleration. This object, and this object would also have the same acceleration as the system because they're all moving together. So again, our goal is to find the acceleration of the system using this formula right here, which is basically Newton's second law. And then we can use that acceleration to find pretty much anything else like tension or the mass of a block or the frictional force or whatever it happens to be. To practice this, I've left a few questions in the description below, so that way you can try them out after I show you how to do this. So without further ado, let's actually go ahead and try to solve a problem here. I've already added some masses to each block. And looking at the system, we can tell that this 8 kg block, the bigger of the two blocks, is going to be responsible for actually pulling this side of the system down and this side of the system up. That 2 kg block is really kind of holding it back. It's almost like it's retarding the motion. And so when it comes to solving for the acceleration, again, we're going to use the net force of a system is equal to the mass of the system times the acceleration of the system. And that net force part is really going to be the accelerating force minus the force that's slowing it down. So in other words, what's the force of this? Well, that's going to be the weight of that block. The weight of an 8 kg block is simply 80 newtons. Minus the force that holds it back. So any forces that hold it back, you subtract, and that force is going to be the weight of the 2 kg block, which is 20 newtons. I'm using 10 for gravity, just to be clear. The mass of the system is going to be 8 plus 2, which is going to be 10 kgs, times the acceleration of the system. And that's pretty much it. Go ahead and simplify that. 80 minus 20 is 60. We can divide both sides by 10, and the acceleration of the system is going to be equal to 6 meters per second squared. And you can honestly probably just do that in your head. Now, once you're done with that, what we can do is we can use that acceleration to solve for anything else in the system. Now, one thing I want to point out is when you solve it as a system, those internal forces disappear. Notice how we never involve tension at all. That's the beauty of it, but the downside is that we can't use this method to solve for tension. So how do we solve for tension? Well, we need to make it reappear by drawing an FBD for either one of these blocks. Now, the reason you can draw it for either one of these blocks is because in this specific case, the tension is the same on either side. So I'm just going to choose a 2 kg block here and draw an FBD for it. So let's call this M1. So I'm going to draw my downwards weight force, M1G, and my upwards tension force, which is going to be bigger than M1G. Why? Because we need a net force upwards to make sure it accelerates upwards, because the 2 kg block, again, is accelerating upwards. And so I can go back to using my regular Newton's second law, which is F net is equal to MA. And in this case, the net force is the bigger vector tension minus M1G is equal to M1A. So therefore, tension is going to be equal to M1G plus M1A. And of course, from here, you can simply just plug and chug and you can solve for tension. I don't think I need to do that because you guys get the idea. So you just plug in 2 there, 10 for gravity, and the acceleration, again, we already found. So it becomes super simple. So this is why the strategy is to always solve for acceleration first of the system, and then you can just use that acceleration pretty much for any other object in that system. All right, and just to prove to you guys that this works in any multi-body system, let's go ahead and take a look at this multi-body system. So let's call this a 4 kg block. Let's call this a 7 kg block. Let's call this maybe another 4 kg block. Let's say we're going to be pushing with 30 newtons. And just to really mix things up here a little bit, let's say that this middle block here has a coefficient of friction of 0.1. Let's find the normal force between block 1 and block 2. So let's call this M1 and let's call this M2, and we can even call this M3. So we want to find the contact force, aka the normal force between M1 and M2. And so the way we're going to do this is, again, first we're going to solve for acceleration. And then once we have the acceleration, we can go back to drawing an FBD for maybe the first block or the second block. The contact force is the same between the blocks, so it doesn't really matter which one you choose. But we can draw an FBD for either of these blocks and then use the acceleration that we are going to find to solve for that contact force. And so that might be a lot that I'm saying, so let me actually just go ahead and solve it. So the first thing we're going to do is we're going to use F net of a system to solve for the acceleration of this entire system. Okay, so remember, the net force of the system is going to be all the forces that accelerate the system forward, which in this case is that 30 Newton force, minus all the forces that retard the system. In other words, all the forces that slow it down. And in this case, the only force that slows it down is the friction on that metal block. So let's put 30 minus the friction that slows it down. And for right now, let's just call it friction on M2. So let's just call that friction 2. And that's going to be equal to the total mass of the system, which is going to be 4 plus 7, that's 15, times the acceleration of the system. Let's actually go ahead and fill in F2 now. So it's going to be 30 minus F2, which is really mu times the normal force on that M2 block. And again, just to fill it out at once, the normal force is going to be equal to the weight because they're in equilibrium, or I should say the block is in equilibrium vertically, so therefore the normal force is equal to the weight force, mg. And so we can replace N with m2g is equal to 15 times the acceleration of the system. Let's actually go and just plug in the remaining numbers here. So it's going to be 30 minus 0.1 times 7 times 10 for gravity is equal to 15. And then obviously you can just solve for acceleration. So this one required a little bit more number crunching, but regardless, as you can see, there wasn't too many steps. Really all you're doing is you're taking the force that pushes it minus the force that pushes it back, finding that net force, dividing by the total weight, and you're done. And so over here, it's going to be 30 minus 0.1 times 10, that's just 1. 1 times 7 is going to be 7. So 30 minus 7 is equal to 15. As our final step, we can put the acceleration of the system is going to be equal to 23 over 15. Okay, cool. Now that we found the acceleration, we can now go ahead and solve for that normal force. Once again, take a look at how normal force was not involved at any given point as we solved it as a system. Again, that's a benefit of doing that as a system, but it's also a drawback because we can't actually use this to find the normal force. So what do? We make an FBD for that 4 kg mass. So let's go and do that. Let's do M1G, the normal force that balances out from the floor. And then we have the force by block 7. Let's just call it F7 for right now. So again, this is the force from block 7 pushing back on it. And we know that that force has to be less than the force pushing against it, which is that 30 Newton force. Why? Because we know that this M1 block is still accelerating to the right. And so there we go, there's our FBD. And what we can do now is we can just, again, normally use Newton's second law, so F equals ma. But again, we're just doing it for this block. So that way we can find the contact force. Okay, let's go ahead and fill everything in. We're going to do 30 minus F7 is equal to the mass that we're currently analyzing, which is M1 times A. And then we can just fill in and solve for F7. So 30 minus F7 is equal to M1, which is 4, times the acceleration, which again is the acceleration of the system, 23 over 15. And again, why is it the acceleration of the system? Because all the blocks are moving together. So this M1 block is going to be moving, or accelerating, I should say, at 23 over 15. Plug it in and just rearrange and solve for F7. I'm not going to do that because that's just math and I know you guys know how to do that. Anyways, if you guys found that helpful, give this video a like and go ahead and practice those problems I have left in the comments below so that way you can actually get fast with this. That's like the important part. All right, I'll catch you in the next video.